All right, this is Coach Williams, and we are going to go over 9.3 notes today. We're going to deal with solving quadratics using square roots. And so this is pretty simple when it comes to the square root itself. We've already covered this in previous chapters and previous units. So this shouldn't be too difficult to start out. We will get to a concept that may be a little difficult at first, but I feel very strongly that you'll be able to grasp it as we move through the problems and examples. But that's later on in the notes. But this will be a longer notes video just because we do go over quite a few examples. All right, so to begin with, square root, we know we have this radical symbol that we use to denote roots. And the square root is just kind of the understood one. If you don't put a number out here in front, it's just we consider that to be a root of 2 or square root. And so just by example, if we had a square root of 4, we know that that is going to equal 2. But we also need to make sure we remember that as long as this is a whole positive number, which is the only way we could do real numbers right now, real square roots, that this actually could be plus or minus, or positive or negative, because a positive 2 times 2 will equal a positive 4, and a negative 2 times negative 2 will also equal a positive 4. So when we take the square root of a positive 4, it could be either one of these roots. And we'll see that here in just a minute on our core concepts as well. Excuse me, the zero of the function, we all should all know how to relate this. What are the other ways we describe the zeros of the function? We call them the solutions. We call them the roots. What else is this referred to as that we covered in just the section right before this one, 9.2? What did we say that the solutions of the roots of the zeros of the function were? Where it crosses the x-axis or the x-intercepts. Okay, so it's the x-intercepts. Okay? All right, so that's pretty much all we really need to make sure we understand our vocabulary terms for this part. Let's look at the core concepts. Whenever we deal with the solutions of a square, as long as this number out here to the right is greater than 0, then as long as it's greater than 0, then x squared equals d will have 2 real solutions, and it's going to be this plus or minus whatever the square root of d is. Okay, remember, just like we did up here, that 4 is greater than 0, right? The number is actually going to be greater than 0, so it's going to have plus or minus. Whatever that square root is, in this case it would be 2. So as long as this is greater than 0 and positive, that's what we're talking about here. If it's greater than 0, it's positive. Then we're going to have 2 versions or two real roots. All right. When d equals 0, so if you have x squared equals 0, when d equals 0, then x is just going to equal 0. It's pretty easy, because 0 times 0 will be 0. So the square root of 0 is just 0. All right, and then if d is less than 0, so if it's a negative number, so if x squared equals some negative number, well, there are no real solutions for that situation, because we cannot get to a negative number by multiplying 2 numbers times themselves. If you multiply 2 positives, you get a positive. If you multiply 2 negatives, you get a positive. So we can't get to a negative number, which is what being less than 0 is in this case. So there's no real solutions for that situation. All right, let's move right into the extra practice here to show you some examples, and hopefully we won't make this video too long and hopefully not too boring either. All right, so we're going to solve for the equation here, but we're going to use square roots. So we're going to, instead of trying to factor this out or whatever methods we've used in the past, we're going to see if we can't find this by using square roots. So I need to get the x squared by itself. What's the first step in getting x squared by itself? What would we do first here? Well, we're going to move this 49 to the other side. Okay, we're going to move the 49 to the other side, which makes it a negative 49, or subtract 49 from both sides. Okay, so then now x squared equals a negative 49. So let's look at our solutions and rules, core concepts again. Is this greater than 0? No. Is it equal 0? No, it's less than 0. So in this case, there is no number that we can multiply times itself to be a negative 49. So x squared, if we were trying to take the square root of both sides, this would have no real solutions. And you could write that if you want, no real solutions. Or you could just write this 0 with a line through it, okay? There are no real solutions. Okay? Number 2, same concept. We're going to get this to where we have x squared equals some number if we can. And in this case, we're going to take this negative 25 across. When we move it across the equal sign, it changes the sign to positive, or we're adding 25 to both sides. And so x squared is going to equal a positive 25. At this point, I'm going to take the square root of both sides. And we all know x times x gives us the x squared. And so x is going to be the square root of x squared. And the square root of 25, this is bigger than 0, right? So it's going to have 2 real roots. And the square root of 25, if you put that in your calculator, is just simply 5. But remember, because it's greater than 0, we have to have a plus version and a minus version of that. So x is going to equal positive or negative 5. Now, for those who are following along and using your calculator, just a little refresher. If you're on your calculator and you want to do a square root, you just take and do second x squared, which is the button right there. That should give you the square root sign. We'll put 25 inside there, hit enter, and it gives you 5. Now remember, the calculator is also only going to give you the positive version, but we know that that is potentially a positive or a negative 5 that will get you to a positive 25. Okay? All right, if the question was asked, why do we put positive and negative? Well, if we took a negative 5 and multiply it times itself, so we have a negative 5 times negative 5, well, then the two negatives would become positive. So a negative 5 times a negative 5 equals 25, and a positive 5 times positive 5 equals 25. So there are actually two different answers here. If you wanted to separate that, you could say, well, x equals a positive 5, or x equals a negative 5. But we can combine that statement into one by just putting a plus and a minus in front of the 5. Okay? All right, number 3. On number 3, we're going to get x squared by itself. So we're going to take this, move it across. All right, I'm going to zoom in just a little bit here so we can see a little bit better. I'm going to move this 6 across. And when I do that, it changes the sign to negative 6. And 6 minus 6 is 0, so x squared is going to equal 0. When I take the square root of both sides, well, the square root of 0 is just 0. Or using one of our core concepts, as we said up at the top here, anytime this is a 0 on this side, then x just equals 0. And that is my one real solution. Okay, pretty simple stuff so far, right? It's not too difficult. Let's move on to the next few examples here. All right, so this one we've got 2x squared plus 84. We need to get the x squared by itself. Well, first, we need to move the 84 across. So we're going to move the 84 across, which means we're going to minus 84 from both sides. So we'll have 2x squared equals a negative 84. And then we need to get x squared by itself even further here. Isolate this x squared. We need to divide by 2 on both sides. Well, the 2's will cancel out to be a 1, and so we'll have x squared is going to equal a negative 42. And here's where we look at our rules again. This is not greater than or equal to 0. It's less than 0. And since that is less than 0, we can't get the square root of a negative 42 and have a real number answer. So this is going to be no solutions. Okay, no solutions, no real solutions. The square root of negative 42 is not possible without diving into imaginary numbers, and we're not going to get to that anytime soon. Okay, number 5, we have a negative x squared minus 12 equals negative 12. We need to move the negative 12 across, which means we're going to add 12 to both sides. Alright, so then we're going to have negative x squared on the left. Negative 12 and positive 12 becomes 0. Alright, and then to get rid of the negative sign, I either multiply both sides by negative 1, or I can just divide by negative 1. Doesn't matter. And the negatives will cancel, so it leaves me with x squared. This becomes still 0. 0 divided by anything is just 0. And because I equal 0, x squared equals 0, then we know that x has to be 0 as well. So x is just going to equal 0. And that's one of my core concepts. The only thing times itself that equals 0 is 0. Alright, on the last one here, we're going to take number 6, I'm sorry, last one on this row. We're going to take the negative 49, move it across, which means we change the sign. We add 49 to both sides. And then I'll have 81x squared is going to equal a positive what? 25. Very good. Positive 25. All right, so then I need to get x squared by itself, so I'm going to divide by 81. Okay, so 81 over 81 goes away. We have x squared is going to equal 25 over 81. Now, the interesting part about this is that I'm going to take the square root of both sides. So I'm going to take the square root of x squared, and I'm going to take the square root of this whole side here. Now, one of our cool little rules that we have about taking these square roots is that we can actually break this apart. We can say, well, that's the same thing as the square root of 25 over the square root of 81. We can break that apart. We can do that. And what is the square root of 25? It's 5. And what's the square root of 81? It's 9. But because this is greater than 0, we also have to remember that this can be a positive or a negative version. So we have plus or minus 5 over 9. Does everybody see how we got to that point? Right? We just took the square root of the top, took the square root of the bottom, and we end up with a positive or negative 5 over 9. Okay, let's look at number 7. On number 7, we need to get 16x squared by itself. So we'll take the 1 and we'll move it across. That will make it a positive 1. So we'll have 16x squared equals a positive 1. We'll then divide by 16 on both sides. 16s will become a 1, leaves us with x squared equals 1 over 16. And then we need to take the square root again, square root of both sides. Okay? Square root of both sides. What is the square root of 1? 1. And what's the square root of 16? 4. 4. 4 times 4 is going to equal 16. But remember, because this is greater than 0, it could be a positive 1 over 4, or it could be a negative 1 over 4. And so in this case, we're going to have x is equal to a positive or negative 1 over 4. And those are the two answers we would have for number 7. So far, so good. Yeah, thumbs up, thumbs down. Yep, we're good. Okay. All right, number 8. We have negative 16 that we're going to have to move across. So we'll take the the positive 16 will become a negative when we move it across. So we'll take that and move it over here. We'll have negative 3x squared is going to equal what? Negative 27. Yes, very good. Now we'll divide by the negative 3, divide by negative 3, and the negative 3's will become a 1. We'll have x squared equals, what's negative 27 divided by negative 3? It's going to be a positive 9 because negative over negative is positive. So this will be a positive 9. And this one works out pretty nicely. We're going to then take what? The square root of both sides. And so we're going to have x is going to equal plus or minus 3. Plus or minus 3. Because a negative 3 times negative 3 equals 9. And a positive 3 times positive 3 equals 9. All right. Again, we're not learning a whole lot new just yet. We're just kind of applying the same principles we know about square roots with more terms in an equation or a polynomial here, right? All right, let's do this last one on this side, and we'll move on to the next page. We've got we need to move this 16 to the other side, which means we will subtract 16 from both sides. Okay, so we'll have a negative 2x squared equals 0. All right, we'll divide by negative 2, and so x squared is still going to equal 0. And anytime it equals 0, we know that x is just going to be 0. So that's a simple one on number 9. And that finishes out the front side of our notes. So let's turn the page. The first one is going to be much like what we've done so far. Nothing too tricky, but number 11 is going to be the one that's going to present us with a little more of a concept issue. So let's look at number 10 here together. And we're going to do what we've done already in the past. We're going to get the squared term by itself, so we need to get rid of the 49. So we'll take the negative 49, move it across. Means we'll add 49 to both sides. We'll have 8x squared equal to 200 when you add those together. Then we'll divide by 8, and x squared is going to equal 25. Again, we know what we're doing here by now. We're just taking the square root of both sides. X times x gives us the x squared. And what times what gives us 25? 5. And because it's greater than 0, x is going to have two possible solutions, the positive and the negative version of 5. All right? All right, so now let's put our thinking caps on here for just a second, because we are going to look at a concept now that's not too difficult, but it takes a little bit of grasping. It's probably going to take me a couple times explaining, and I'm going to start hearing this. Oh, I see it. Oh, I got it. All right, so just pay attention for just a minute. We have 2x plus 7, in parentheses, squared equals 49. Okay? So we have this whole thing is squared. Okay? The whole thing is squared. Equals 49. Now, and I'm going to graphically or visually, visually, I'm going to show you as I talk my way through it here. I'm going to show you what I'm talking about. We have something squared. What is the square root of something squared? It's just the something, right? If I told you you had x squared, and I wanted you to take the square root of x squared, what is square root of x squared? It's x, right? So if I said you had 10 squared, what's the square root of 10 squared? 10. If I told you you had 25 squared, what's the square root of 25 squared? 25. So now, take that idea and apply it to this right here. I have something, 2x plus 7, squared, right? It's squared. What's the square root of that? 2x plus 7. Exactly. So if I take the square root of both sides right here, if I take the square root of both sides, then the square root of 2x plus 7 squared is just 2x plus 7, right? All right, now, I also know that if I take the square root of 49, it's a 7. But remember, because it's greater than 0, you have a positive 7 and a negative 7. So what I'm going to have to do here is solve for a positive and solve for a negative. So I'm going to have 2x plus 7 equals a negative 7. And I'm about to find out what x would be to make this equation equal a positive 7 and what would make it equal a negative 7. Okay, so let's solve now. Okay, at this point, I'm going to move the 7 across. That means I'm going to make it negative, so I'm going to subtract 7 from both sides. And so this means I'm going to have 2x equals 0. I'll divide by 2, and when I divide both sides by 2, x is going to equal 0. Does everybody see that? Okay, that's the first one. All right, and then on the second one, I'm going to do similar steps here. I'm going to take this positive 7, and I'm going to move it across, which means I have a negative 7. And so 2x is going to equal a negative 14. Don't think in terms of multiplication here, because that's a common error. Negative 7 minus 7 is still an addition subtraction type situation, not a multiplication deal. So the two negatives don't make a positive. You have negative 7, that's a negative 14. Now I will divide by 2. Divide by 2. X is going to equal a negative 7. Does everybody see that? All right, and those are my two answers. I'm going to have x equals 0 or x equals a negative 7. And remembering the concept here, I just had something squared, and I took the square root of both sides. That something just happened to be an equation still, and we have to solve for that equation. All right, so what about number 12? What about number 12? Can I find out what that one's going to be? What would be the first thing I do? Okay, bring down the x minus 4. So, well, yes, because that's the square, right? It's the square of x minus 4. I've got something squared, and so the x minus 4 is the something. So I'm going to have x minus 4. And what's the square root of 0? It's just 0. So we've got 0. So now I don't have to worry about two versions, do I? I don't have to worry about a plus version and a negative version. I'm just going to have basically a 0, right? Just the one solution. So if I take that now and I solve for x, what do I get? What's the first thing I do? I'm going to just take this positive. Yeah, I'm going to take this negative 4, make it positive by moving it to the other side, and x just equals 4. That one's easy breezy. X just equals 4. All right, and again, we're just solving this by the squares themselves. Okay. On to number 13. Number 13. I need to get the squared term, and I'm doing this outside the video, but I need to get the squared term. Use the little quotes there. I need to get the squared term by itself. Think about this as being like an x squared. How would I get rid of everything around the x squared to get it by itself? I'm going to divide by whatever's in front of the x squared. Now, in this case, I actually have an equation inside that parentheses. But I need to get this squared term by itself. So I'm going to divide by 81. Divide by 81 on both sides. And what that does is that gets me this squared term by itself, right? So those 81s will cancel. I have 3x plus 1 squared equals this 49 over 81. Okay? Now at this point, this is where we're going to have to apply our new little concept. Something squared equals 49 over 81, right? And for us to find the answer, we're going to have to take the square root of both sides. I'm taking the square root of something squared. I'm taking the square root of that side as well. All right, so I'm going to take the square root of both sides, meaning that this one's just going to be 3x plus 1. And this one, remember, I can break it into two pieces, so I can have the top and the bottom. This is going to be a plus or a minus, and it's going to be plus or minus, what's the square root of 49? 7, and 81? 9. So my solution so far is going to be 3x plus 1 equals plus or minus 7 over 9. Now at this point, I'm going to have to find both options, right? I'm going to have to find both options. And what I would end up having to do here is, and there's a couple ways you could approach this. Okay, there's a couple ways you could approach this. You could just put this in the calculator and find out what 7 over 9 is. Okay, if we did that, we find out that it's what? What's 7 over 9? Oops, let me type it in correctly here. 7 over 9 is just going to be 0.77777778. Okay? Yeah, it's 0.7777 basically. All right, now, and then what I could do is say, well, okay, I know to find x, I'd have to move the 1 across. So I'd have to subtract 1 from both sides. So if I move that across, I'm going to have minus 1. And then, to find x, I'd have to divide by 3. Right? The whole thing by 3. So if I use a calculator, this would probably be pretty easy. I could say, watch this. Now remember, I'm going to do a plus version, and then I'm going to do a minus version, right? A positive and the negative. So if I did 7 divided by 9, and then I'm going to, actually let's do this. Let's put in parentheses, 7 divided by 9, and then I'm going to subtract 1. I'm going to find that answer, and then I'm going to divide that by 3. All right, now that gives me some crazy decimal answer. If I want the fraction form of it, I just hit math, enter, and I find out that that's negative 2 over 27. Okay, so that's one way I could do that, right? I could put it in the calculator, and that's the positive version, so I know it's going to be negative 2 over 27 is one of my answers. Now, if I wanted the other one, I would take this right here, and instead of a positive, I would make this, let me insert this, I'm going to insert a negative number in front of that, and that's going to give me a negative 1.777777. I'm going to divide that by 3, right? Because that's all I'm doing here is this part, and then I'm dividing everything by 3. And that gives me this crazy decimal answer, and I can find the fraction for that one by just hitting math and enter. And that gives me negative 16 over 27. So using the calculator, I could find out those answers fairly easily. Okay? Just remembering to have both versions. If you're the question's asking about doing the fraction one, once you have a decimal answer like this right here, then you can do math, the math button on your calculator. It says fraction form basically. You hit enter again, it should give you the fraction form there. Okay, now that's one way we could do it. We could do it by hand. If we did it by hand, we just have to convert this 1 to a 9 over 9, and we could work with fractions that way. All right, I'm going to show you one other option that you could do to get these answers pretty easily, not having to deal with adding and subtracting the fractions. But let's just say, I'm going to pull this off to the side here and just kind of show you a little quick demonstration. We had 3x plus 1 equals, and I'm going to do it with just one of the fractions first. I'm going to do it with the positive 7 over 9. So at this point, I could say, well, you know what? I don't want to deal with fractions, so why don't I get rid of that 9, and all I'm going to do is multiply by 9 on both sides. Okay? When I multiply by 9, the 9's cancel over here. This becomes 27x plus 9 equals 7. The fraction goes away. Does everybody see that? That's pretty cool because now I don't have to worry about adding and subtracting fractions. I'll end up with a fraction in the end, but I don't have to worry about dealing with them during my calculation process. Now, I'm going to take and subtract the 9 from both sides. I end up with 27x equals a negative 2. I divide by 27. X is going to equal negative 2 over 27. If you'll notice, that's what I got for my positive answer at the top. Okay, so that's another way you could approach this problem. If you didn't want to try to use the decimals and the decimal scared you in the calculator, you could do it this way just by multiplying by the 9, getting everything out of fraction form until you get your final answer at the end. Final answer is in a fraction, that's fine, no problem. You just didn't have to deal with them while you're in the middle of the problem and doing the calculations. All right, let's look at number 14. All right, number 14, again, we're going to say that this is like an x squared. We need to get that squared term by itself. So I need to get rid of the 16. I'm going to divide by 16 on both sides. So now x minus 3 squared equals 25 over 16. And at this point, again, I'm just taking the square root of both sides. And the square root of x minus 3 squared is just x minus 3, right? So I'm going to have x minus 3. The square root of 25 is 5. The square root of 16 is 4, and that's a plus or a minus. Okay, it's a plus or a minus. And now, what I have to remember to do here is x is going to equal either a positive 5 over 4 plus 3, or x equals a negative 5 over 4 plus 3. Because remember, all I'm doing is taking this negative 3 and I'm going to add it to that side. So I'm going to have to worry about a plus version of 5 over 4 plus 3 and a negative version of 5 over 4 plus 3. So that's why I have these two different ones I'm solving for both, options. When I do that, this one right here, I'm going to end up with x is going to equal, when I add these together, you can do it on the calculator, then change it back to a fraction if you want to, or just get a common denominator here. If I got a common denominator of 4, well, 3 times 4 is 12, so 12 over 4 plus 5 over 4 is 17 over 4. So that's one of my options. And then 12 over 4 minus 5 over 4 would end up being 7 over 4, right? 12 minus 5, 7? Yeah. So we'd end up with 7 over 4 is my other option. Okay? So those would be my two solutions for number 14. All right, number 15 works out a little more nicely. We don't have to deal with the fractions. We're not dividing by anything. Remember that we've got something squared, and the square root of that is just the something. And then 64, take the square root of that, is a plus or a minus 8. Okay? So we're going to add this 3 to both sides. So we're going to add 3 to both sides. And then to get the x by itself, we have to divide by the 4, right? So let's do this. We're going to have 4x is going to equal, if it's positive 8 and positive 3, that's 11. Then we'll have a 4x equals, if it's a negative 8 plus 3, it's a negative 5. Does everybody see how I got to that point? Right? I just took this, and I have a positive version, and I have a negative version. Okay? Might even write that in here. That's a positive version. That's the negative version of the 8. Okay? So then I just divide by 4 on both of these, and I have my answer. So x is going to equal 11 divided by 4, or x is going to equal negative 5 divided by 4. And those will be my two answers or solutions for number 15. Okay? All right, this is the tougher concept really to kind of grasp, is that you've got this squared something and you take the square root of it. And then if you throw in trying to find fractional squares, then that makes it even a little more difficult. But that should get you through this part through 15. Now the next part, we're definitely going to just work with the calculator on it, because it's actually asking us to round solutions to the nearest 100ths or 100ths. So let's solve for number 16 through 21 using the calculator. Here we're going to take the 6 and move it across. This means we're going to minus 6. So x squared is going to equal a positive 2. When I take the square root of both sides, x is going to equal the square root of 2. And remember, it's plus or minus, right? We have a plus or minus version of that. And if I look at the calculator and say, well, second x squared, which gives me the square root sign, second x squared of 2 gives me 1.414, etc., etc., etc. We only need to go to the second decimal place, the hundredths place. So we have to remember also again, x equals plus or minus, and then we're going to put in 1.41. And that's it. Nothing more to that one. Number 17. Number 17, we're going to take the negative 12 across. Means we're going to add 12 to both sides. Okay? So we'll have x squared equals 15. Well, x squared equals 15. Taking the square root of both sides, we'll have x equals the square root plus or minus the square root of 15. If we put that in the calculator, second x squared, 15. Remember that the calculator only gives you the positive version here. We're going to have 3.87. So x is going to equal plus or minus 3.87, rounding to the nearest 100th. Okay, on this one we're going to subtract 25 from both sides. To get rid of the 25 on that side there, we're going to have x squared equals 24. We'll take the square root of both sides, so x is going to equal plus or minus the square root of 24. And we put that in here. We get x equals plus or minus. Now this one we're going to have to round up, and that's going to change that to a 0 or tens place, which means we're going to change that to a 9. But we're still going to the hundredths place, so it's 4.90. Okay, plus or minus 4.90. All right, that's the answer to number 18. Number 19, we'll move the negative 4 across. It means we'll add 4 to both sides. We're going to have 3x squared equals 18. We'll divide both sides by 3. And when we do that, we're going to have x squared equals 6. We'll take the square root of both sides, right? We're going to square root both sides here. So x is going to equal plus or minus the square root of 6. This is going to be 2.45 when you round that 4 up here. You have 449, so it would be 45 when you round it up. So we'll have plus or minus 2.45. That's your solution for number 19. Okay, number 20 and 21, pretty much the same. Same principle. We're just going to take this 5, move it across. You're going to have 6x squared equals 15. Then you're going to have, dividing by 6, you have x squared equals 15 over 6. Then we're going to have to take the square root of both sides, and that'll leave us a plus or minus over here. We're going to have, in our calculators, 15 divided by 6. And so the answer is 1.58 when we round it. So x is going to equal plus or minus 1.58. Okay, and then on number 21, number 21, we're going to take this 20 across, which means we minus 20 from both sides. All right, we're going to have negative 4x squared equals a negative 2. We'll divide by the negative 4. 4's will go away. X squared is going to equal a positive 1/2. And so again, we'll take the square root of both sides, and that means that x is going to equal plus or minus the square root of 1/2. So we'll take 1 divided by 2, square root of that. We'll have 0.71. 0.71 should be the answer for number 21. Okay, let's try to work through this last part of it here. Number 22. A ball is dropped from a window, height of 81 feet. The function is h equals this function here, negative 16x squared plus 81. They want to know how long it takes it to hit the ground. When it hits the ground, what is the y value? What's it hitting the x-axis right there? So that means y is 0. So at the ground, h is going to be 0. So we'll just say 16x squared plus 81 is going to equal 0. We're going to solve for x. just like we've been doing. So we'll take the 81 across. That means we subtract it. We're going to end up with negative 16x squared equals negative 81. I'm going to divide by negative 16. And x squared is going to equal 81 over 16. When I take the square root of both sides, then I'm going to end up with x equals plus or minus 9 over 4. But can it be negative? Time can't be negative. So we don't worry about the negative one. We just do 9 over 4. And 9 over 4 means that x equals 2.25 seconds. So at 2.25 seconds, it's going to hit the ground. Okay, number 21, last one. The volume of a cone has a height of h and radius of r given by this formula. And they want us to solve for r. So let's do that first. Volume equals 1/3 pi r squared h. I'm solving for r squared. So I want to get everything out of there except for the r squared. That means I'm going to multiply by 3 to get rid of the 3's. Okay? If I do it to one side, I do it to both. It also means I'm going to divide everything by pi and h. That way my pi's and h cancel, and I have pi and h over here. So r squared, if I solve for r squared, or r, I'm going to have r squared equals 3v over pi h. If I solve for r, then r is going to equal the square root of 3v over pi times h. And then they give us the volume and they give us h and say what is the radius r. So plugging that in, we'll have r equals the square root of 3 times the volume, which is 27 pi, all over pi times h, which they said was 4. We got 4 there. Volume is 27 pi. The pi's cancel. 3 times 27 divided by 4. Well, we put that in the calculator because that's a lot easier to do, right? 3 times 27 equals 81. Divide that by 4. And I'm going to take the square root of 20.25. And so my radius is going to equal, r equals 4.5. And in this case, it's inches. Okay? So that one is not too difficult as long as you can figure out how to get r by itself. All right, I hope this has helped you guys get a grasp of 9.3. That concludes the notes. And this should get you ready for your practice for 9.3. So you guys have a great day.